This question requires us to determine the truth sets of this inequality. It's a compound inequality actually. This is minus 1 less than x squared minus 2x minus 1 less than 2. So for us to be able to solve this inequality, we have to split it into 2 and then solve the individual inequalities. And then we'll determine the intersection of the solution of each inequalities. This is what I'm saying. This is minus 1 less than x squared minus 2x minus 1, which is less than 2. So I'm going to take the first part, which is minus 1 less than x squared minus 2x minus 1. That's the first part of the inequality. Let me solve this. When I say the first part, I mean this one, this part of it. Then I'll show you the second part. So this inequality is a quadratic inequality that we have to solve. Now, if you have been following my videos on inequalities, quadratic inequalities specifically, this is how we normally solve. I usually set one side of inequality to 0. So if I move minus 1 to the right hand side, we'll be having 0 left, which is less than x squared minus 2x minus 1. Then the minus 1 goes and turns to a plus 1, right? So this is 0 less than x squared minus 2x. Minus 1 plus 1 is 0. Now, you know that if s is greater than 0, for example, it means that 0 is less than x. Therefore, if 0 is less than x squared minus 2x, that means x squared minus 2x is greater than 0. That's the implication. Now, on the left hand side, we have a quadratic factor. Let's factorize. What is common to these two? We have x. So x squared divided by x, that's x, minus 2x divided by x is minus 2. And this is greater than what? 0. Now, I will say, let the factored expression x into x minus 2 be made equal to 0. So I can determine the critical point. If this is so, from here, x is either equal to 0 or x minus 2 equal to 0. And by implication, x is equal to 0 or x equal to positive 2. These are the critical points of this inequality. So what we'll do is, we'll determine the truth sets of this inequality, this very one. I'll draw my number line and fix these 2 points on the number line. We have 0, right? And we have 2. After all, 0 comes before 2. So to the right we have plus infinity, and to the left we have minus infinity. So this inequality, this number line is into 3 regions. This is the first region, this is the second region, and this is the last region. So we have from 0 to minus infinity, in between 0 and 2, then from 2 to plus infinity, 3 regions. So which of these 3 regions will satisfy this inequality we are solving, this one? Remember we are trying to solve this inequality, and we split the inequality into 2. This is the first part of it that we got. So when we split the second part, we're also going to solve that one, and I told you we're going to combine the intersection of the solution. That gives us the truth set of this very inequality. So now we are solving the first one. Which of these regions satisfy this inequality? Let's see. Alright. The inequality we resolve, this is it, right? From here we got this, from here we got this, and from here we are here now. And we got here. So 1, 2, 3, 4, 5, they are all the same. I hope you know that they are all the same. So this inequality that we are solving reduced to this very one. Let me asterisk it. They are the same thing. So let me choose a number in each of these 3 regions. Alright? In between minus infinity and 0, we have numbers less than 0 actually. Okay, such as minus 1. So I can use minus 1 here. In between 0 and 2, we have numbers like 1, 1.5, and so on. So I can use 1. And from 2 to plus infinity, we have numbers bigger than 2, such as 3. Let me use 3. So what I'm going to do now, I'll plug each of these numbers into this inequality. You know that this one and this one they are the same. Okay, so I'm using the simplified form of the inequality now to solve. Let me plug each of these numbers here. Whichever one that gives me a number bigger or greater than 0, that region satisfies the inequality. Now, this is the trick. If this region 1, satisfies the inequality, region 2 will also satisfy it. Sorry, region 3 will also satisfy it, while region 2 will fail. Okay, but if region 2 satisfies, the remaining two regions will fail. So, if I plug in -1 here, this is -1. Okay, let me do it here. -1 times -1 minus 2 is -3. -1 plus -3 is +3. And +3 is bigger than 0. That means this first region will satisfy the inequality. So I'll just draw a circle and take it to the left to show that this region will satisfy it. And I just told you that the second region will fail. But let's test it. If I plug in 1 here, this will be 1 times 1 minus 2, which is -1. It will give me -1, right? And -1 is a number that is less than 0, not greater than 0. So this second region will fail. For the third region, if you plug in 3 here, this will be 3. Multiplying 3 minus 2 is 1. So 3 times 1 is 3. And 3 is a number bigger than 0. So this third region will work for it. So the same thing, I will take my arrow to the right. So the left region and the right region satisfies, while the middle region fails. This is the solution on the number line. But if I want to use inequality notation, I'll be saying x is less than 0, x less than 0, and x greater than 2. X less than 0 and x greater than 2. If I'm using interval notation, so what I will say, this is from -infinity. You understand me now? Between -infinity and 0. Now, because the inequality didn't come with an equal to, you understand, an equality sign, it means that the critical points do not satisfy the inequality. So 0 and 2, they do not satisfy. So I'll be using this bracket, -infinity to 0, union 0 to plus 2 to plus infinity, 2 to plus infinity. Let me just tell you, if 0 and 2 were to satisfy the inequality, I would have written this like this: -infinity to 0, union 0 to plus 2 rather to plus infinity. Okay, but since they do not satisfy, then this will be an incorrect interval notation for this solution set. All right. So these are the solution, or this is the solution to this very inequality. Now, this is the first part. What is the second inequality that we have from this combination? I've taken this first one. So what I'll be taking now is this. I'll take this. Do you understand me? So this is x squared minus 2x minus 1 less than 2. That's what I'm solving now. So in the same fashion, okay, x squared minus 2x minus 1, 2 will cross to the left and turn to minus. So we have 0 left at the right hand side. Now this is x squared minus 2x minus 3 less than 0. Okay, just keep following. This is a quadratic equation at the left hand side. A quadratic expression at the left hand side. So we have to solve. Yeah, I have 1 here attached to x squared. If I use the 1 to multiply -3, it's going to give me -3. Now, the coefficient of x here is -2, right? -2. So, which two numbers in life will I multiply together to give me -3, and I'll add them to give me -2? If I think correctly, the numbers are +1 and -3. Yes, +1 and -3. 1 times -3 is -3. 1 plus minus 3 is minus 2. So I'm going to write this left hand side like this. X squared. In place of minus 2x, I'll write plus 1x minus 3x. Then minus 3 follows less than 0. Alright. We are attempting now to factorize the left hand side. That's what we are trying to do. So I'll factorize that grouping them in twos. 2, 2. Take the first two, take the last two. What's common to this first two? We have x. X squared divided by x is x. X divided by x is 1. What's common to this last two? We have minus 1 is common and 3 is also common. So if I divide this by this, I'll get x. Minus 3 divided by minus 3 is positive 1. And this is less than 0. X plus 1, they are common in brackets. Pick one of them. Then x minus 3 will form another bracket. And this is less than what? 0. So what we do now is this. From the same way we solve this equation, when we have gotten the factorized form of this, I will simply say, let x plus 1, x minus 3 be equal to 0, so that I can determine the critical point. This means that either x plus 1 is 0, or x minus 3 is 0. And this means that x is equal to minus 1 or x equal to positive 3. These are the critical points. You get me now? So what I'll do is to determine the solution set of this inequality now by first drawing the number line. So the critical points will be minus 1 and 3. Of course, minus 1 will come before 3. So we will have to the left minus infinity, you know that, and to the right plus infinity. So we have three regions as usual. The first region between these two, the second region between these two, and the last region between these two. You get it? So which of these regions satisfies the inequality? Now, let's choose values in each region. We can easily choose the value in this region. Numbers in between minus 1 and 3 include 0, 1, 2. So I can use 0. So less than minus 1, we have minus 2, minus 3. I can use minus 2. Greater than 3, 4, 5, 6. I can use 4. So let me plug in each of these critical points in this factorized form. I can plug it here. I can plug it here as well as this and this as well. Even this. But this one is most simplified. That's why I'm using this one. The same thing I did here, I used this one to test for each of the regions. I could have used any of the above 4 expressions, okay? So if I plug in minus 2 for x here, let's see what we produce. Plug in minus 2 here. Minus 2 plus 1 is what? Is minus 1. Minus 2 minus 3 is minus 5. If you multiply these numbers together, you're going to get positive 5. And positive 5 is bigger than 0, not less than 0. So region 1 will fail. I then need to solve for region 3. It will also fail because 4 plus 1 is 5. 4 minus 3 is 1. 5 plus 1 is bigger than 0 because 5 plus 1 is 5. But if I use 0 in region 2, 0 plus 1 is 1. 0 minus 3 is minus 3. 1 times minus 3 is minus 3. And minus 3 is a number less than 0. So region 2 will work. Simple. Now, if I attempt to determine the solution set to this inequality, this second one, this is for the first one, right? Now, what is for the second one? It's very easy. Minus 1 is less than s and s is less than 3 because the solution set includes values of x between minus 1 and 3. Take note, minus 1 and 3, they are not part of the solution set because there is no equality here. You get the point now? If we had equality there, I would have shaded the two circles, something like this. But that's not the case now, so I can't shade. Alright? So the solution set is this. Minus 1 is less than x and x is less than 3. That's it. Or I can use interval notation minus 1, 3. Now, the question is, having solved for the individual inequalities that we have here in this combination, you know this is the inequality we are trying to solve, and we split it into two inequalities, giving us this and this. And we've gotten each of the solution set to these two inequalities. What is now the solution to this compound inequality? I said initially that the solution of this inequality is the intersection of these two. So where these two inequalities, where their solutions meet, that is the solution to this particular inequality. Check. To do that, I'll draw a number line. Minus infinity plus infinity. All the critical points, I will fix them there. The critical points are 0, 2, minus 1, 3. Let me write them in order. Minus 1 will come before 0, 0 will come before 2, and 2 will come before 3. Do you agree? Yes. Based on the solution, see what happens. We have for minus 1, for this second inequality, the solution is like this. Am I correct? Yes, that's for this second one. For the first one, the solution is like this. Let me raise the arrow upwards. 2 is going this way, right? 0 is going this way. 0 is going this way. Okay. The question is, where did they intersect? That's the question you will ask me. I made this one higher than this so that we can see it very clear. For this first inequality, we have 2 to infinity, 0 to minus infinity, and that's what we have here. Then for the second one, the solution is like this, and that's what we have here. So you can see that they intersected at this point, at this regions rather. Am I correct? Yes, that's what they need. So this is how we have the solution set. This one now is between minus 1 and 0, right? And this one is between 2 and 3. So the solution set is like this. Minus 1 less than x less than 0. Union 2 less than x less than 3. Okay, let me write it this way. Between minus 1 and 0, that's for this. Union between 2 and 3. So any of these two solutions, they are the same actually. They give the solution to this compound inequality. The solution set is the set of numbers x such that minus 1 is less than x and x is less than 0. Union 2 is less than x and x is less than 3. Alright, so any of the three works as a solution of this particular inequality. Alright, thank you for watching this video. I hope you like it. Keep supporting by subscribing to this channel. Like the video and share it to your friends and to your classmates. I am the complex analyzer and I will see you in the next one. Just keep watching.